Today we want to answer the question, is virtualization necessary for cloud computing? Hopefully by the end of this short video, I'll be able to outline what cloud computing is and if it's necessary for cloud computing. Just a quick caveat, this video is going to exclude virtualization as it applies to microservices and network. I can't tell you about virtualization until I recount some of the sordid tales of my corporate past. When I first got into the server business a long time ago, enterprises shied away from putting three-tier architecture components on the same server. Your three-tier architecture had web, app, and database. These were almost always three different machines for reliability and better intercommunication. When apps are being developed or tested, you may have seen them all on one machine though. As we've discussed in the past, three-tier architecture, web servers only presented web presentation layer data, applications ran the business logic, and the database servers stored the data. Also, these servers were inherently redundant, so they were costly. Once you had them configured, they'd sit there idling. So you had three servers that were at least $2,000 to $5,000 a piece sitting there idling. If you measured the overall usage of these machines, it wouldn't be unusual for them to be at 1 to 10% utilization. If your marketing department thought 1 million visitors were going to come to your website, you tended to do something called building to peak, which is building to the scale of your environment to accommodate the worst case scenario possible on the high side. So if you thought you were going to have 1 million visitors, you'd have to build for 1 million visitors, even though only 50,000 visitors may have shown up to the site. This was super costly, but there were early startups that got media attention, usually TechCrunch, and the site would literally crash, which was a bit embarrassing for a startup, especially one in tech. So, to answer the question, is virtualization necessary for cloud computing, we need to wait a bit longer. I'd like to do a quick recap on what virtualization is. Virtualization allows you to put multiple logical servers on a single server. So you have this large server, you install a hypervisor, and then you divide the resources of that one server into small chunks which operate independently of each other logically. This way you get the specialization that enterprise computing demands without having to allocate a single server to each discrete function. Here's another problem that virtualization solved, which is probably the most amazing benefit we get from virtualization. So strap in for another sordid corporate story. So again, when I worked back in the hosting business back in the 90s, we would manage systems for clients. Let's say you had a very specific HP server sitting in a cabinet and you had an identical cold spare sitting next to it. Sometimes the running server would fail, so you take the hard drives out of the failing machine and put them into this cold spare and you turn it on. In some cases, that computer may not turn on and start working, although in theory it really should have. There are a bunch of small nuances that would have caused this cold spare not to work. For instance, this could have been due to difference in firmwares between the servers or some slight change in manufacturing versions, even though those model numbers were identical. It may have been a patch that was applied to one machine but never initialized because the server hadn't been rebooted in months. It could have been something else, so you were never guaranteed an easy recovery. In the end, this meant that you had to image a new machine from scratch, carefully reinstall all the applications, and then copy the data off of those hard drives from the failed machine back to the new server, test, and then run. So at the basic level, what does virtualization do for us? It allows you to have single-purpose servers, still separated in every regard, but sitting on the same piece of hardware. This allows you to fully consume the resources of each server you put into production with very little idling. But if you were to take anything away from this video, it's the resolution to the story I just told. Virtualization allows us to normalize CPU, RAM, and storage resources. Normalization is the idea that types and origins no longer matter. CPU, RAM, storage space, and network are made common. Where they come from, what brand of hardware no longer matters. In other words, the origin of those resources isn't taken into account. They just need to be there. Here's why, finally, virtualization is needed for cloud computing. When we build systems for clients, we'd like to allocate specific servers to them. The fact that those servers were used 1% or if they were perpetually clobbered 24 hours a day didn't matter. Those servers cost the service provider these things: the full capital cost, network, software licensing, monitoring, management, space, power, and cooling. This server could only be used by one client. Putting someone else on this server would be impossible, and there was no easy way to logically separate this single resource amongst clients. There was something called shared hosting, but it wasn't something most enterprises would tolerate unless it was a simple brochure type of website. This is akin to renting an apartment to a family, and if the family goes out to dinner, you can't rent that apartment for 3 hours while they're out to another family. So going back to the cloud computing, where you built a platform full of servers, you sell access to the cumulative resources of those servers. So you buy a handful of servers and you could give 10 CPUs, 10 gigs of RAM, and 10 gigs of storage. You can sell this at an hourly rate, and when it's given back to you, you can have it virtually rented by another entity. So the buyer benefits because they can buy in small bite-sized chunks, and the service provider benefits because they fully utilize their capital investment of servers. Of course, they'll need to build a little overhead for surges of business, but the more automation they employ, the more competitive their rates can be. From an uptime perspective, since these instances are virtual, fully inclusive, and lighter, you can stop, start, clone, and move them around in a way that wasn't possible before. So cloud computing is really predicated on the premise that you have virtualization. The virtualization doesn't make the raw compute necessarily cheaper, but it does two important things. One, buyers can buy in small chunks with little to no commitment. Two, sellers can sell their entire capacity and scale their environment without having to match their hardware, thanks to normalization we discussed earlier. If you need 10 racks of hardware, buying that in the cloud probably will be more expensive, but the fact that you could have slowly scaled up to 10 racks of gear, one CPU at a time, is the real benefit here. Last little story that involves virtualization and VMware. The first time I saw VMware run was on a friend's laptop. He was an engineer for a software company, and his role was to take some of the applications his prospective clients were running and create a proof of concept on how the software would help integrate these various applications. So he'd literally mock up their environment on his laptop, load some test data, and demonstrate to the client how integration would look using their actual applications and test data. Installing Windows Server OS's SQL Server and several enterprise applications on a laptop is not the best idea if you still need to check your email, fill out expense reports, and collaborate with your colleagues, and not have IT run down the hall and tackle you. So he would build these proofs of concepts on a virtual instance that was fully isolated on his laptop. Once the client saw the proof of concept, he could delete that VM instance, which was literally a single file, or copy it off to a different device. Meanwhile, his pristine laptop, imaged by IT the day he was hired, was in perfect shape since all that craziness lived in its own self-contained instance on his laptop. It literally is a single virtual hard drive file. I hope this video helped explain how virtualization helped the cloud become the cloud. The overall idea is that you are abstracting operating system instances from hardware. To think about microservices, which we covered last time, you are abstracting code from the operating system. But we'll cover that in a future video when we go into the world of DevOps. Thank you again, and I look forward to seeing you when we release our next video. Take care.